This is the experiment to calculate the half power beam width of dipole antenna and Yagi antenna. So first we'll look into dipole antenna. So this is the experimental setup which is given to us. So in the signal generator, what you have to do is keep the operating frequency at 2.5 gigahertz and keep the RF power level max. Then keep this as an amplitude modulation and ensure that this RF is on, because if you keep it off, it is of no use. So keep the RF on. So after keeping the RF on, you have to take a scale and measure this particular distance. Okay, this is 4.6 centimeter. So after measuring the distance of 4.6 centimeter, then with the help of the formulas, you have to calculate. See, lambda is C by F. We have kept the frequency as 2.5 gigahertz. So here we use 2.45, keep it as 2.5 gigahertz. You'll get lambda. Then S is equal to 2d square by lambda. D is 4.5 or 4.6 centimeter you use, you'll be getting the distance. So this is the S means distance of separation between the transmitting antenna and receiving antenna. So here the distance what you're keeping, it should be more than 3.3 centimeter. So now they are in far field, more than 3.3 centimeter. Next, what you need to do is, now we have kept this one in this plane. This is called H-plane. So in this H-plane, now you try keeping the antennas of transmitting and receiving like almost straight. Okay, so that maximum power is transferred, like radiated, and here it is received. So at that point, here you have to come, and in this channel, you just have to increase the position and note down the VPP reading. So just multiply this one and this 50 millivolt value. So that is the first initial thing. Okay, so 0.68 he has got, so you have to fill this value for clockwise as well as anti-clockwise. It's the same reading. So first initially we have kept it in H-plane. So here it's E-plane, this is H-plane now we are doing. Okay, so then what you have to do is, in this part they have given us like the scales. So here initially it is like 0 degree. Okay, then we'll turn this towards us, this 10 degree. Then after making this towards 10 degree, as shown here, this is moving in anti-clockwise direction. Then again you have to come here, note down the VPP reading, multiply with the channel 1 the voltage, and you have to write it in the anti-clockwise form. First we are doing anti-clockwise reading in H-plane. Then move this receiving antenna from 10 degrees to 20 degree. Okay, repeat the same procedure. Come here, move the position, you will be getting this value, the VPP value into this voltage, you will be getting the value for 20 degree. Okay, for 20 degree. Similarly, move the receiving antenna to 30 degree, 40 degree, 50 degree, and so on. For all the readings you have to take the VPP reading. Here you will be getting around like 0.1, 0.001 like that. So you have to increase the volts per division. So it's already increased, you'll be getting a very small value. Then after this is done, get the receiving antenna back to the 0 degree position. Now what you have to do is, you have to go in clockwise direction. So in order to go in clockwise direction, see in the back side we can have another type of a white line for reference. So now you keep this one at 180 degree exact. Okay, so when you keep this at 180 degree, this is like our 0 degree initially. Then come to 170, this will be giving the reading for clockwise 10 degree, clockwise 20 degree, clockwise 30 degree. So this will be easy to determine the value. Okay, because we can't go that side and see the readings. So this white line will give you the readings. So in the same way, you have to come till 180 degree overall, and you have to take the VPP reading at the corresponding angles from this output oscilloscope. Okay, after this is done, get the receiving antenna back to the same place of 0 degree. Then what you have to do is, now we have done with H-plane readings. So clockwise readings, anti-clockwise readings. Then what you have to do is turn the transmitting antenna from vertical position to horizontal position. Okay. Similarly, the receiving antenna from vertical position to horizontal position. So when you turn this, now it becomes into E-plane, electric field plane. Okay. So now after keeping it in E-plane, the same procedure, 0 degree. Now it is in E-plane, 0 degree. Take the VPP reading. Okay. After taking the VPP reading, come here in this, come to 10 degree, then again note down the reading. So first we will do it in anti-clockwise direction till 180 degree. After this is done, again come to 0 degree, go to the back side and go 10, 20 in clockwise direction, and for every 10 degree note down the VPP reading. Okay. So this is the second part of the experiment where we have to do with Yagi antenna. So the same procedure goes for the setup. Keep the power on, RF max, keep the RF on, AM, set the frequency at 2.5 gigahertz. Okay. Then turn on the power supply for the oscilloscope. Then after that, the transmitting antenna and the receiving antenna both are kept in vertical position. So this is in H-plane. Okay, magnetic field plane. Keep this at 0 degree. Measure the distance. This is same 4.6, the very first thing. Okay, so you'll be getting same 3.3 centimeter. Just keep this far away. Then take down the reading. Okay, this is the first reading for H-plane at 0 degrees for clockwise and anti-clockwise. Take the VPP, multiply with the channel 1 voltage. Then same procedure, you have to come in anti-clockwise direction for 10 degrees, then measure the voltage value, and so on. You have to come similar to 180 degree and complete the values. Then come to 0 degree, go in anti-clockwise direction to clockwise direction now. So in clockwise direction, measure the values and you'll be getting the output readings. So after this, come back to 0 degree. Then after doing it in H-plane, we have to keep it in horizontal position and do it in E-plane. So we'll just turn this slowly, keep it in E-plane. This is electric field plane. Same way, even in the receiving side, keep it in E-plane. Okay, after keeping it in E-plane, same at 0 degree, take the reading of the VPP maximum, whatever you get, go in clockwise direction and anti-clockwise direction.